An IoT and AI-based flood monitoring and rescue system. Abstract. One of the biggest natural disasters India had ever faced was floods in Western Maharashtra in August 2005 and August 2019. The primary objective of this research is to provide an innovative and sustainable solution required to monitor flood situations and perform rescue operations in the worst affected Sangli, Kolhapur, and Satara districts. This attempt aims at providing IoT-based flood detection and AI-based rescue operation through the system. This research makes use of Internet of Things and artificial intelligence technologies to provide a reliable and implementable solution for the above problem. This innovative approach uses Arduino Uno microcontroller for flood detection based on rise of water level, humidity, atmospheric pressure, and temperature measured through BMP180 sensor. Raspberry Pi has been used for carrying out drone-based rescue operations by detecting the number of people stuck in flooded regions using YOLO object detection algorithm and notifying concerned authorities about them through web portal and mobile application. Keywords: artificial intelligence, drones, flood monitoring system, flood rescue system, Internet of Things. Introduction. The world's climate is drastically changing because of natural calamities like hurricanes, tornadoes, volcanic eruptions, earthquakes, tsunamis, storms, floods, and which is only the outcome of human activities such as pollution, cutting trees, and many more hazardous activities. These natural disasters cause great damage and destroy the smooth living of human life, causing the reconstruction of all things including the most important basic needs: food, shelter, clothing, and water. The flood is one of the most frequent natural calamities India is ever facing. In August 2005-9, due to heavy rainfalls, the Western Maharashtra faced severe problems specifically in Sangli, Kolhapur, and Satara districts and impacted livelihood of people, housing and farmlands. Kolhapur and Sangli had received heavy incessant rainfall and had broken the record of many previous years. Many of them evacuated to safer places, but because of lack of management, precautions, and technological advancement, flooding caused loss of human life, livestock, destruction of plants, property, and deterioration of health conditions owing to waterborne diseases. Recently in 2019 there was heavy rainfall more than 2005, breaking the one-month record in just 9 to 10 days, and the water level was above the danger line of Panchganga and Krishna River. The heavy incessant rainfalls in Radhanagari, Kalamawadi Dam area, rising of urban areas near river basins in Kolhapur and Sangli area, backwater of Almaty Dam causes the swelling of Krishna and Panchganga River, and so the disaster has happened and many inhabitants near the river banks of Krishna, Panchganga, and Koyana have been displaced. People faced a lot of hardship to evacuate to safer places. Hence, it is important to design a flood control mechanism. The pervasive computing technology is useful in such areas, which utilizes context to deal with relevant information and services in an effective manner. 6. This paper proposes the IoT and AI-based flood monitoring and rescue system, which is divided in 2 parts. The IoT-based part is for prevention of flood, which detects the rise in water level and triggers alarm for alerting nearby people. The AI-based rescue part detects the number of people stuck in flooded regions and notifies concerned authorities through web portal and mobile application. Section 2 explains previous research in related fields. Section 3 explains the methodology. Section 4 analyzes the result of the experiment. Section V concludes the paper with an outline of contribution and the future work. 2. Literature review. Numerous literatures related to IoT-based sensors and computer vision for flood monitoring and mapping were outlined: 1 by Arshad B. ODR, Bartholomew J., Pradhan B., Versta Evel N. and Perez P. This attempt reviewed different applications aided with IoT and computer vision for better monitoring and mapping of floods. Wahida M.D. Shah, F. Arif, A. Sharan and Aslinda Hassan presented a flood warning system 2 based on IoT that was able to detect water level and calculate the speed of water level increased and alert nearby residents. The experiments were conducted in a controlled environment for testing the implemented system. Pan, J, Yin, Y, Seong, J, Luo, W, Gui, G, and Sari, H developed a network of automated surveillance composed of distant measuring stations and a control center. 3. They conducted tests using 3 methods, including the method of difference, dictionary learning and deep learning. Ellen Ridolfi and Pier Giorgio Mangsiola proposed water level observations from drones at a dam site 4, which makes use of a sensing device composed of a drone and a camera to assess the water level. A general-purpose design for context-consciously dependent flood control system with regard to context consciousness was demonstrated by YD Asari I, Nugros L and YD Awin in the form of WSN-based flood detection and monitoring device model 5. Reference 7 shows how drones can be used during the times of natural disasters like Kerala floods in India. Since the ban imposed on flying drones in India had been lifted 8, they can be very effective during flood rescue operations. As per reference 10, drones can also be used to deliver critical humanitarian aid. Customized drones can be built for carrying out rescue and relief operations in a better manner. 11-12. To the Amazon Web Services cloud platform where data processing and analytics will be generated. Data about atmospheric pressure, water level height, humidity, and temperature is collected using only one sensor called pressure sensor, BMP180 barometric. ICULN 2003 is used to show water level by blinking LED at each level. Data made available on a single website and mobile application is accessible to the concerned authorities and subscribed users for flood monitoring and decision-making. People who subscribe to this system can also receive alerts and notifications regarding water level in certain areas. Drones can be used by integrating Raspberry Pi as a rescue mechanism that will improve the quality of rescue operations and help in finding people stuck in flood and providing relief resources to needy people. With the help of camera attached to drones, pictures of flood-affected areas are captured and those images are processed using YOLO v3, You Only Look Once, state-of-the-art deep learning-based object detection algorithm of computer vision library named Image AI to find the count of people stuck in flood. It performs object detection on any image using pre-trained models trained on COCO dataset. Using its object detection class allows us to detect and recognize 80 possible objects. To make it simple, this item is only concerned about detecting number of people, ignoring other objects. This mechanism can help the government in rescue operations and to provide required resources to needy people. NEO6M GPS module is used to get the latitude and longitude of the location wherever help is required. The data is uploaded to AWS Cloud with the help of Nodemco ESP8266 Wi-Fi development board. Alerts and notifications about the water level in certain areas are also sent to the subscribed users. The web portal and mobile application give information about safe places and flood-affected places, so people can move to safe places. Also, there is information about available shelters for flood victims. This system also provides facility for donations for flood victims through the web portal. Information about all volunteers for each area and various government schema is made available. For results. Following results are obtained through this research at Walchand College of Engineering, Sangli. Fig 1. System Architecture Fig 2. Total number of August 2019 flood victims in Sangli and. As shown in Fig. 1, all the data from the sensors are collected. Kolhapur districts by microcontroller Arduino Uno. Nodemco ESP8266 Wi-Fi Fig 2 visualizes data of 1000 people collected from collector development board is used to upload data from Arduino Uno office of Sangli that shows total number of people affected in August 2019 floods in Sangli and Kolhapur districts. The X Fig 5 depicts average altitude observed in September 2019 at axis shows districts whereas y-axis represents number of Sangli. This helps to understand the water level heights people represented on y-axis and x-axis. V conclusion. The IoT-based early detection of the flood helps to save many lives and enables real-time updates about water level to nearby people so they can relocate to safe places with their valuables. The detection helps to prevent damage of houses and businesses due to floods. This innovative approach assists concerned authorities to have access to real-time data in order to generate reports and perform analysis. Express gratitude to Walchand College of Engineering, Sangli for providing opportunity for conducting this research. Acknowledgement. We express gratitude to Walchand College of Engineering, Sangli for providing an opportunity for conducting this research.